Hello everyone, welcome back again to the course Comprehensive Slope Stability Analysis using Plaxis 2D. This is tutorial number 9, Slope Stability Analysis using the Hardening Soil Constitutive Model. So if you remember in previous lecture, we did this example using Plaxis 2D. Safety analysis of this slope, but we used the Mohr column constitutive model. So in this example, we will do the same example as the previous, the same geometry of the slope and the same amount of surcharge load, but we will use the hardening soil model. Also, we will explain some of the important results in this tutorial, such as safety factor in Plaxis 2D. Also, we will talk about failure surface and deformation, where and how slope might fail after running the safety analysis. Also, we will talk about what is the plastic points in Plaxis 2D. So this is also very important, and it shows us a failure point in the soil. Also, we will explain the effective principal stresses or total principal stresses in Plaxis 2D. And also effective stresses in x direction, sigma x, and effective stresses in y direction, and the importance of these parameters for practice in slope stability analysis. Also, we will shortly talk about active pore water pressure or hydrostatic pore water pressure and excess pore water pressure and steady pore water pressure in Plaxis 2D. Also, we will shortly talk about the suction, which is more important when dealing with the rainfall effect or a dry season effect. Also, we will have a relative shear stress. This is also very important parameters in Plaxis 2D. Also, it shows us how the slope is close to a failure. Also, we will state the elasticity parameters, because in Mohr column we used a fixed elasticity, but in hardening soil model the elasticity is stress dependent, so it changes. So what will we do now? We have this example from lesson 8, tutorial number 8. We will try to save this project under a different name, so we don't need to model it for everything from the beginning. So I will copy this title, and we have this Plaxis project from previous lesson. We click on File and Save Project As. So I will paste the title in here right now. This is tutorial number 9, as you can see. So we will do only changes in material properties. So we click on soil and click on show material. So we can see, unlike the Mohr column model, the elasticity is not a constant value in all the soil body. As we can see, it is changed and depends on the stress level. We can see the elasticity is not fixed. So if you select this one in Mohr column, you will see only one fixed elasticity for all the soil. Also, we have something called a relative shear stress. It's close to 1 at failure at safety analysis, but it is not 1. It is maximum 0.9 in a surcharge load phase. This is because at safety analysis phase, the Plaxis automatically reduces the shear strength parameters of the soil until the soil is failed. So that's why in here we can see the relative shear stress at some location is equal to 1 or near 1. This was for this lecture. I hope it was clear and understandable. If you have any question, you can write in the comment section. Thank you for watching. See you in the next tutorial.